Good morning, ladies and gentlemen. Today we are on page 111 of your student journal, and our objective or our goal for the day is today I will represent, and represent usually means to show. So I will represent or show mixed numbers, period. Okay, so let's look at our vocabulary. Our first words are just reminding us again about the definitions of a numerator and a denominator and what they each mean. And then they are reminding us what an improper fraction is, that is greater than 1 with a numerator that's greater than the denominator. And then they're reminding us that a mixed number has a whole number and a fraction mixed together. Okay, today we have again two different sets of steps that I'm going to let you just look at, but I think it's easier if I show you what they'd like us to do for these. Okay, so I'm going to get started right away. Here is my first problem, and it says, what fraction, I'm sorry, ladies and gentlemen, I moved it. What fraction is represented in the number line? Okay, so how I'm going to look at this is, remember when I do fractions, my denominator tells me how many the one whole was divided or partitioned into. Not one whole number line, but one whole. So I'm going to look just at my number line from 0 to 1 and look at what was that one whole partitioned into. That one whole was partitioned into 1, 2, 3, 4 parts, which means my denominator is a 4. So again, I don't look at one whole number line, I look at one whole, meaning 0 to 1 or 1 to 2 or 2 to 3 to see how many parts that was partitioned into. So that tells me all my denominators are going to be 4. On my whole number line, every single one of these intervals I can put a 4 at if I wanted, and I could keep going, but I can stop there. So this would be 1/4, 2/4, 3/4, and then 1 is equivalent to 4/4, 5/4, 6/4, and 7/4. So what I see here is I see 7/4. So this number line goes all the way up to 7/4. As a mixed number, I could also say what this is. So how many wholes do I have? I have one whole. I don't have this whole. From 1 to 2, I don't have the whole part. So I actually only have one of the wholes. And from 1 to 2, how many parts do I have? I only have 1, 2, 3 parts out of the 4 that one whole was cut into. So my fraction is 7/4, but my mixed number is 1 3/4. Okay, let's look at another one of these. My next one's a little different. They say represent 3 1/2 using a model. Label as an improper fraction and a mixed number. Okay, so what does this mean? This 3 is my whole number, so it means I have 3 wholes. 1, 2, 3 wholes. Let me shade those in. And then this half means the 2 denominator means I have one whole that was cut into or partitioned into 2 parts. And the numerator of 1 tells me I have one of the parts. Okay, so this is what 3 1/2 looks like. But if they want it as a fraction, that means that I need to divide all of these up, because my fraction is 2 because my whole was cut into 2. So I need to go back and cut these into 2 parts as well to make it work. So now that all my wholes are cut into 2 parts, how many parts do I have? Well, I have 1/2 here, another half. So I have all these halves. So how many halves do I have? I have 1, 2, 3, 4, 5, 6, 7 parts, and each part is worth 2, or the holes were cut into 2. So I have 7 halves, or 7 over 2. Okay, let's try some together. So we are on page 112, and here is our first problem. What fraction is represented in this area model? Okay, so in this area model, okay, remember our denominator is what was each hole cut into. Not the entire thing, but one hole was cut into. So how many parts was this cut into? 1, 2, 3, 4, 5. And if I look, each hole was cut into 5 parts. So our denominator is 5. How many parts do I have though? Well, here I have 5. I have all 5 of those. I have all 5 of those. I have 5 of those, and here I have 2. So how many parts do we have total? Well, 5, 10, 15, 20. We have 22 parts total, and each one is out of 5. Okay, as a mixed number, what do I have? Well, we have, how many holes do we have? We have all those holes. So we have 1, 2, 3, 4 holes. And then this one is not whole. So this one was cut into 5 parts, which is our denominator, and we have 1, 2 of the 5 parts. So as a mixed number, it's 4 2/5. But what's important to know about these is they're equivalent or equal. They're the same, they're just written differently. Okay, let's try one with a number line. This one says represent 2 3/8 on a number line, label as an improper fraction. Okay, so we're gonna need a long number line, and you probably don't wanna go ahead on this one. So it means I have 1 hole, I have 2 holes, plus I actually have more than that. So I have 1 hole, I have 2 holes, plus I have 3/8 of another hole. So of this one, I have to cut it into eighths. So 1, 2, 3, 4, 5, 6, 7, 8, and I have 3 of the pieces. Okay, that's what that means. Now this is where it gets a little tricky. If I want to make this as an improper fraction, we actually need to cut up all the holes. So let's go back and let's cut this one into eighths too. So let's do it in half first, and then let's make it into fourths, and then let's cut those in half again. Let's do the same thing here. Let's cut that in half, let's cut it in fourths, and then let's cut those up. Now this is where it's going to be hard because we have to write really small, and my markers don't always write really small. Okay, so this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 1 is equivalent to 8/8 because when the numerator and denominator are the same, it's equal to 1. Okay, so after 8/8, what do we get? 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, and 2 is equivalent to 16/8 if you didn't make a mistake. Okay, so we had 2 holes, and then after 2, we have 3 more. So we have 17/8, 18/8, and 19/8. And that's where we stopped. So 2 3/8 is the same or equivalent to 19/8. That one is our answer. And that's a really squished with a lot of work there. Okay, so ladies and gentlemen, you have the next 3 pages to try on your own. Have a nice afternoon.